Hello guys, today we are going to fracture the concrete part of the building. Before moving further, make sure to hit like and subscribe to my YouTube channel. You can also support me on Patreon. I'm going to release the vellum multi-layer cloth sim after this RBD tutorial. So today we are going to fracture the concrete only since we need to do some fixing. And after 2 days I will drop another tutorial in which we will fracture remainings of the building. Also, I will upload tutorials after every 4 days. Take a geo node. Object merge our building prep null. We are getting a 1402 name attribute. This is because we had given each class a separate name based on the class attribute. Let's bypass the connectivity and modify the code. If we see the spreadsheet, we can see all glass have the same name attribute. Now take a group from the name attribute node. This node makes a group based on the name attribute. If we middle mouse, we can see prim groups such as concrete glass and another one that we assigned on the name. Now I had made a Python script that isolates the group with one click. In this lecture I'm not going to teach you Python, we will learn it in the coming days. I will give the code on my Patreon page to everyone. As you can see, with one click it isolates all the groups and it also adds a null with naming. This is very useful when you have a bunch of groups and you need to isolate manually everything. I will give this code in the description. Now take a split node. Select the rooftop. We will use the name original attribute to select. We missed the cloth group. Go back to the building prep node. Take a split node and isolate the cloth and add the name attribute to it. So as you can see, the interior of the building is not available and it's totally empty. While demolishing the building we won't see enough details. The reason for separating the rooftop is, we will copy and transform the rooftops and add it as a ground for every floor. First, let's fix the walls for fracturing. Take a normal node. Before splitting the rooftop, add a connectivity node and set the connectivity type to primitive. Now take A for each named primitive. Select for each end node, instead of name write class and piece attribute. If you display the begin node, we can see the walls have single-sided geometry with no thickness. Seems like I forgot to scale down the building. Go inside the building prep node and add a transform node and scale it down to 0.01. There are a few pieces that are quite small in size. If we subdivide it with higher resolution, then the big pieces will get a lot more division, which will slow down the PC. To fix this, we will use the bounding box function, which will separate the small pieces with the given threshold value. Take a subnet and dive inside it. Now take A for each primitive node. Since we had already added the connectivity node previously, we need to select for each end node and turn on the piece attribute and write class. Now take a primitive wrangle node and write this code. This code will calculate the bounding box size of each axis. After that, we are creating an attribute that multiplies all the axes. Now take a split node. We need to create a new parameter. Click on the little gear icon and add a float parameter. You can give whatever name you like. In my case, I will give size. We need to connect the split after the for each end node. Now duplicate the output node, and for the second one set the output index to 1. Now in the split group write this. The new parameter that we had created, right-click on it, and select Copy Parameter. In the group paste it as Paste Relative Reference. In the group type select Primitive, since the bbox size attribute is present on the primitive level. I forgot to change that, but later I had changed it. Dive out from the subnet and now click on the little gear icon. There also add float parameter. Copy the parameter from the subnet and then paste it as a relative reference on the split parameter. So now whose bbox size is less than 0.02, it will come on the first input. Take a divide node. Turn off the convex polygon and turn on the bricker polygon. Reduce the size to 0.29 along all axes. Now take a polyextrude node. Reduce the distance to -0.02. Take a reverse node. Because we had extruded in a negative direction, so the normal will mesh up. Take a normal to recalculate the normal. After that, attach a fuse node. Copy all the nodes and connect them to the second input. Take a facet node and connect after the divide node. In the polyextrude, reduce the distance to -0.08. Now merge both the fuse node and connect two for each end. Turn off the single pass and let's see how it looks. Seems like we did something wrong. Let's figure it out. Select the facet node and turn on the unique point. Now in the polyextrude node, turn on the output back on both node. Now take a copy and transform node. Display the copy to transform node and template view the rest of the wall. Let's see how many copies we need to fill the floor. We need 8 copies. So let's increase the total number to 8. Now translate it to a negative y-axis. This looks good to me. Now take a polyextrude node. Reduce the distance to -0.22 and turn on the output back. Take a group node. First, let's delete the geometry which is above the rooftop. Now duplicate the blast node and toggle on delete non-selected. Merge both the normal and blast node, then feed it into the loop. In the group node, type the group name as hard edge. Set the group type to edges. We are doing this because we are going to remesh it. So to maintain the shape, we are going to feed this group into remesh. Take remesh node. In the hard edge group, selects the group that we just made. Now increase the target size to 0.25. Take a rest node. Take an attribute VOP node and dive inside it. Now take an anti-alias noise node and an add node. Connect add and noise to global position. Add the noise to the current position. Promote the noise parameter to the SOP level. In the signature, select 3D input 3D noise. Take a VDB from the polygon node. Turn off distance VDB and turn on fog VDB. Now take a scatter node and scatter around 500 points. Take another scatter and reduce the point count to 20. Take a point replicate node and connect it to the second scatter. Reduce the point per point to 9. In the shape, select circle. Now change the orientation to the ZX plane. In this way we will get more small pieces in between the big pieces. Increase the uniform scale to 10. Merge both points. Now take the Voronoi fracture node. In the second input of Voronoi, feed the points. Let's wait for a minute to get fractured. Take an exploded view and see how the fracture looks. If you go to the spreadsheet and see that the name attribute has changed. To fix that, go to the Voronoi fracture node and change the name attribute to append. Now in the piece prefix type underscore. Now let's restore the original position of the interior wall. We had stored it as a rest attribute. Take a point wrangle and write this simple code. Cool, as you can see, we get some nice edge details, but we are still missing the interior detail. Take a normal node, if in case any normals get messed up. Now delete the rest attribute using the attribute delete node. Take an RBD interior detail node. Reduce the detail size to 0.05. This will add more subdivision to the inside faces. You can see the difference before and after that node. Now turn on the noise scale visualization. By visualizing this we can get the idea of where more noise gonna applied. The red area will have one value and it gets blended towards the green with a value of 0. Increase the depth bias to 0.915. Increase the noise frequency to 3.6 along all axes. Now take an RBD pack node and cache the pack node. Turn on the name and named it concrete. Since this is a very big building we can use Boolean fracture for highly detailed fracture, but my PC can't handle that method, so I'm going to use Voronoi fracture for the second one. Take a scatter node and set the force total count to 4000. Now take a Voronoi fracture. This is going to take so much time, around 7 to 8 minutes. So let's first put it into manual mode and change the fuse setting in Voronoi node. Change the name attribute to append. And in the prefix write underscore wall underscore. If we put only an underscore then the name will be similar to the previous one, which can create issues while simulating. Take a file cache node and cache it to disk. After this we will add interior details. Cache it to disk. Take an exploded view to see how the fracture pieces look. Now take an RBD interior detail node. Reduce the detail size to 0.05. You can adjust the value according to your PC configuration. Increase the noise frequency to 4. I'm not going to add many details in this since my PC can't handle it. You can increase the value as per your PC specifications. Take an RBD pack node and connect it. Cache it. Now merge both the cache node. Take an RBD unpack, take two nulls and connect it to hires and proxy output of unpack. Thank you guys for watching. I will upload another tutorial in 2 days. In that one we will fracture the remaining building parts. If you found this tutorial helpful, please like, share, and subscribe to my YouTube channel.